All right. So the next lesson, or actually the last lesson of this unit, is on combinations. All right. So I think I hinted to this earlier, a couple lessons ago, that when we're doing permutations, kind of introduced the idea of combinations as well. So combinations is the number of arrangements. However, the number of arrangements actually does not matter. Or the order, where the order does not matter. So, okay, so the important difference between this combinations and permutations is that combinations, the order doesn't matter. And yeah, I'm going to do my best here to explain the difference between combinations and permutations, because from my experience, this is probably the differentiating between combinations and permutations is the most challenging part of this unit in general. All right, so so let's go right into the example here. So we have a committee of 3 is being chosen from a group of 5 women and 7 men. Okay, so we want to make a committee of 3. And we have 5 women and 7 men to choose from. So we want to know how many possible committees can be formed, right? All right, so this part A here is that they are assigned roles as president, vice president, and secretary. Okay, so we have 3 spots, right? And each one of these spots are what we'll call kind of like different, they all have labels. For instance, this first one would be the president, this would be the vice president, and this would be the secretary. All right, so we want to choose from the group of 5 women and 7 men. All right, so in other words, there's 12 total people to choose from. So for the president, we have 12 options. Okay, so I'm going to use the fundamental counting principle. We can also use permutations to answer this question. All right, so there's 12 possibilities for the president, and now if one person's taken the president role, then we only have 11 left for vice president. And then we have 10 left for the secretary. And what you would do here is you multiply these 3 together. All right, so 12 times 11 times 10. And that is equal to, I'm not going to try to do that in my head, 1,320. Okay, so the other way, so this is using the fundamental counting principle. The other way we could have answered this question is recognize that it is a permutation. So 12 pick, if we had gone 12 pick 3, so that was going to equal, actually, I don't have that option on my calculator here, so I'm just going to use the formula. 12 factorial over 12 minus 3 factorial, which is 12 factorial over 9 factorial. Okay, so that is equal to, I should have the same number here. 12 factorial divided by 9 factorial. And yes, we get 1,320. Okay. Now for this question, again, since we're assigning roles, the order that you choose the people matter. Okay, so order matters. And that's why this is a permutation. All right, so I'll draw a line here. So this is a permutation. All right. Now, another question, so we're going to go right to part B here, is that let's say we want to create a committee of 3, right, from these 12 total people, but then there are no restrictions. So that means that we are not assigning roles. All right, so for instance, let's say I choose person A, person B, and person C as like one possible committee. If I was instead to choose person B, and then person C, and then person A, these would be 2 different permutations, but they're actually the same combination. Okay, so this would be a same combination, but different permutation. All right, so like if I chose person A, then person B, and person C, it's the same combination as if I chose person B, C, and A, because these two would form the same group. So they're the same combination. However, if we were to like put this into the context of like part A example here, where person A is the president, person B is the vice president, person C is the secretary, and then instead person B is the president. So this is the second one here. Person B is the president, person C is the vice president, person A is the secretary. These would be two different permutations, right? Because they would be given different roles, right? So the order that you pick them matters. Whereas they're the same combination because it's just the same three people in general. All right, so combinations are more general in a way, and permutations are more specific. All right. So to answer this question, what you'll notice is that on your calculator, there's also an NCR button. All right, so this is red and choose R. Okay, so in this case, we want to answer this question, it would be 12 total people to choose from. And so it would be 12 choose, and we're choosing 3. Okay, so this also has a formula to it, which is not programmed into this calculator. So before I write out the answer to 12 choose 3, maybe right here, I'm just going to write the formula. So this would be n factorial over n minus r factorial. Okay, so this should look familiar because this is the permutation formula. However, we're also going to divide it again by r factorial, all right, which would make this a smaller number than if a permutation, because there's the combinations would, in terms of combinations, it's going to be a lesser amount than permutations because the order doesn't matter that you choose the people. All right, so here, 12 choose 3 is going to be equal to, so we'll go 12 factorial over 12 minus 3 factorial divided by 3 factorial. All right. Okay, so that's 12 factorial. I know that's a really big number, so I'm just going to leave it as 12 factorial divided by 9 factorial, 3 factorial. All right, so this one here, when we work this out, calculator, 12 factorial divided by, bracket, 9 factorial times 3 factorial. Now close the bracket, equals 220. All right. Okay, so this is the answer for this question. So there's 220 ways of picking just 3 people without assigning them positions, all right? Because the order that you pick those 3 people doesn't matter, compared to like part A here, where the order did matter, right? If the order that you chose the people would be assigning positions, all right? So what you'll also notice is that for 12 pick 3 here, we got 320, or sorry, 1320 is 12 pick 3, whereas 12 choose 3 is 220. All right, so there's a lot less combinations than permutations, because again, the order does not matter. Right? I know I sound like a bit of a broken record, but yeah, so this is kind of like the trick. This is determining whether the question itself is a permutation or a combination question. All right. I think this is probably the best example I could use to kind of illustrate that concept. All right. Okay. Cool. So let's go on to part C here. This is now C and D. This is where the men and women comes into play. All right. So let me just scroll back and see the numbers here. So there were 5 women and 7 men. Okay. To choose from. So right here in the brackets, I'm just going to put 5 women and 7 men to choose from. Okay. All right. So we want a committee that has 2 women and 1 man. All right, so this, again, the order that you choose the 2 women does not matter, right? Because we're not assigning roles. So this is a combination question. Okay, so combination because the order that you choose the 2 women does not matter. All right, so to answer this question, we're gonna basically the answer here is going to be there's 5 women to choose from. So 5 choose 2. And then there's 7 men to choose from. And we want to just choose 1. So there's 7 choose 1 ways of choosing the 1 man. There's 5 choose 2 ways of choosing the 2 women. And then to get the answer in general, what we're going to have to do is multiply these together. Okay, so it's going to be 5 choose 2 times 7 choose 1. All right, so yeah, this is good. You probably have the button on your calculator where you can just punch it in, but in this case I don't, so I'm just going to have to write out the formula, work it out that way. Okay, so 5 choose 2 is 5 factorial divided by 5 minus 2 factorial, 2 factorial. And then we have 7 factorial divided by 7 minus 1 factorial and 1 factorial. Okay, so this is going to equal, what's 5 factorial? What is, I think it's 120, but just make sure. Yep. So 5 factorial is 120. So 120 over 3 factorial is 6 times 2 factorial, which is 2. And then we're going to multiply that with, okay, 7 factorial is a big number, so I'm not going to pretend I know that in my head. Divided by 6 factorial, and 1 factorial is just 1. All right, so we have 120 divided by 12. I'll just do that in my head. So 120 divided by 12 is 10. And 7 factorial times 6 divided by 6 factorial is just 7, right? Because 7 factorial, I don't want to write equals here, but this is the same as, maybe I'll do it in a different color here. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. I don't think it'll let me write the 1, but, and then 6 factorial is 6 times 5 times 4 times 3 times 2. So these would cancel with these. So this whole thing here is actually just 7. All right, so this is, the answer to this would be 70. Okay. Cool. And again, if you can just, if you wanted, if you punch in 5, choose 2, it's going to be 10. If you choose 7, choose 1, it's going to be 7. So if you have that button on your calculator, which you should, right at the end, choose R button. Just makes things a lot quicker. All right. Now the last one is the committee has at least 2 men. All right. So for these questions, whenever you spot the word at least, or you may spot the word at most, you have to split this up in 2 cases. All right. So in order to have at least 2 men, what can you have? You can have 2 men and 1 woman. So that's a possibility. Or you can just have 3 men in this committee of 3. All right. So here there's going to be 2 different possibilities. So we're going to split them. When you spot the word at least or at most, you want to break it down into the different cases. All right. So we want to figure out the number of ways of getting 2 men and 1 woman. All right. So again, there were, just get there, 5 women and 7 men to choose from. So the number of ways of getting 2 men would be 7 choose 2. And I'm going to have to multiply that with the number of ways to get 1 woman, which would be 5 choose 1. Now for the or part, so this would be the number of ways of getting 2 men and 1 woman, or we can get just 3 men. So in the end, what we're going to do is we're going to be adding the totals up of both these cases to get the total. So to get 3 men, it's going to be 7 choose 3. Okay. Technically, I guess you could write times 5 choose 0. All right. Now 5 choose 0 is actually 1. Is this here is equal to 1? Okay, because if you think about it, there's only one way to choose no women. All right. Yeah, let's go. All right, so 7 choose 2 is 7 factorial over 7 minus 2 factorial, so 5 factorial, 2 factorial, multiplied by 5 choose 1, which is 5 factorial over 4 factorial plus, all right, 7 choose 3 is 7 factorial over 7 minus 3, which is 4. So 4 factorial, 3 factorial, and times 1. All right, so I'm just going to leave that there. Okay, so what is this going to equal? All right, so 7 factorial divided by bracket 5 factorial times 2 factorial, which is just 2, equals, okay, so this is 21. All right, so 21 times 5 factorial divided by 4 factorial is just equal to 5. Plus, all right, 7 factorial divided by 4 factorial divided by 3 factorial equals 1. No, that's not right. 7, let's try that again. 7 factorial divided by, well, I think I just put in brackets, bracket 4 factorial times 3 factorial. Close the bracket, equals, okay, that's more like a 35. Okay, so this is going to equal 21 times 5 is 105 plus 35. So the answer there is 140. All right, cool. Yeah. So this this lesson itself is yeah, it's a little bit trickier when not being able to do this in person, like on the whiteboard in front of you guys. So hopefully this kind of makes sense. I think the practice, it's pretty important for this, for you to do your practice, the worksheet, all right, to practice with. All right, cool. All right, guys, have a good one.